Hi everyone, in today's lesson from Unit 2, we'll be taking a look at how to classify triangles by their sides and angles, how to apply the triangle inequality theorem, and how to apply the triangle angle sum theorem. The triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the third side. So that means if you take and add two side lengths together, such as 5 plus 6 in our list, we get 11. 11 is greater than 9, the third side. Try another pair, 6 plus 9, and we get 15, and that's greater than 5. And finally, the third pair would be the first and the last numbers listed. 5 plus 9 is 14, and that's greater than 6. Since every sum is greater than the third side, we definitely have a triangle. However, there's a shortcut to this theorem. Rather than doing all three pairs of sides, you can test it out by taking the shortest two sides and compare them to the third side. We have 5 plus 6 is 11, and 11 is greater than 9. So yes, definitely. Alright, I'd like you to take a few minutes, pause the video, and try the next 6 questions, and then come back to check your answers. Alright, let's see how you did. In the first case, all three sides are equal, so we know that 9 plus 9 is definitely going to be greater than 9, because 18 is greater than 9. So that's a yes. And this is actually an equilateral triangle. In the second case, just be careful. Use the shortest two sides, not the first two listed. 8 plus 4, we want to compare it to 16. 12 is less than 16, so this is no. You could not make a triangle whose sides are 16, 8, and 4. And the third problem, the two shortest sides given are 8 and 2. And check that one out. 8 plus 2 is exactly equal to 10, so this is a no. Right? It's got to be greater. Right? These sides would not form a triangle. In number 3, we have 7.2 and 12.3. So add those two together, we get 19.5. But that's less than 24.1, the third side. So the answer is no. These side lengths do not form a triangle. And number 5, the two shortest sides are 4.2 and 11.9. When we add those two together, we get 16.1, and we're comparing it to 15.8. So that's true. It's greater, so that's a yes. In our last case, our two shortest sides are 18.5 and 4.7. And we want to compare that to 22.1. We'll add them up and we get 23.2, which is definitely greater than 22.1, so this is a yes. Okay, our second theorem for the day is the triangle angle sum theorem. And it states the sum of the interior angles in a triangle is 180 degrees. Okay, so if you add up all three angles in the triangle, you're going to set it equal to 180. So in our first example, where it says try it, you can pause the video and give this one a try and come back and check your answer. Okay, so here's how we would approach it. Take 2x plus x plus 4 plus x plus 16 and set it equal to 180. Combine your like terms. Remember that if you're working on the same side of the equal sign, you just want to use addition or subtraction as you see it. Don't. In this case, we would just add all the x's together to get 4x. Don't subtract. There's no subtraction yet. And then we want to take and combine the like terms of 4 and 16 together to get 20. So 4x plus 20 is equal to 180. Now we're going to take and subtract 20 because we're trying to eliminate it on the left. So to keep things in balance, do the same thing on the right-hand side of the equation. So 4x equals 160, take and divide by 4, and we get x is equal to 40. Quick way to check your work, plug that 40 back in. 2 times 40 is equal to 80. 40 plus 16 is 56. 40 plus 4 is 44. And if you add 80 plus 44 plus 56, you do get 180. So I would strongly suggest you check your work that way. Sorry about that. And number 2, we want to take and add our 3 angles. We have 5x plus 7 plus 3x plus 11 plus 90 is equal to 180. You could take and subtract 90 from both sides right away and then set the sum of the 2 angles equal to 90, but we'll go ahead and do it all the way through. Okay, so find your x's. 5x plus 3x would add up to 8x. To that, we're going to take and add the 7, the 11, and the 90, and that's going to add to 108. So we have 8x plus 108 is equal to 180. Take and subtract that 108 from both sides. We end up with 72. So we have 8x is equal to 72. Take and divide by 8, and we get x is equal to 9. Again, you'd want to take and check your answer by plugging 9 back in for x and making sure that your 3 angles add up to 180. Alright, the third part of our lesson is classifying triangles by their sides and their angles. Or angles and sides, because I think angles comes first in our chart. We're going to have an additional type of triangle for this side, and that is the equiangular triangle. An equiangular triangle is where all angles are equal. And it would look like this. You'd have 3 congruent angles. Okay, an acute angle has 3 angles that are less than 90 degrees. A right triangle has 1 right angle, so come in and put the little box to indicate that that's a right angle. And an obtuse triangle has 1 angle that's greater than 90. Look at that big angle right there in the corner. Alright, for classifying triangles by their sides, first we have an equilateral triangle, has 3 equal sides. An isosceles triangle has 2 equal sides. We're going to change that to say has at least 2 equal sides. And finally, a scalene triangle has no equal sides. So technically, an equilateral triangle is also isosceles. Okay, so you can use your chart to classify each triangle as equilateral, isosceles, or scalene. Number 1, it's equilateral. All 3 of those sides are equal to 8. And number 2, none of the sides are equal to each other, so it is scalene. And number 3, we have 2 equal sides. That creates an isosceles triangle. And in number 4, we have 2 equal sides, so it is isosceles. In 5 through 8, it says classify each triangle as acute, obtuse, right, or equiangular. So the first one, number 5, all 3 angles are less than 90, so it is acute. And number 6, we have a right angle, so it is a right triangle. And number 7, 115 degrees is an obtuse angle, so we have an obtuse triangle. And finally, on number 8, all 3 angles are equal, so it is equiangular. Alright, in the next group of problems, a little bit of space here. I know I didn't give you much space. It says classify each triangle, and it says draw a picture to help. So having a picture always helps, or usually helps. Right, so I have triangle ABC, and it says that we have to draw it so that AB is congruent to BC. So mark those two sides congruent. Number 10, it says triangle DEF with a measure of angle E equals 90. That means we have a right triangle. So when I draw my right triangle, and I put that 90-degree angle in there, I want E to be at that vertex. So I have DEF. Right, and number 11, it says draw a triangle JKL. And read this description before you start drawing. It says JK must be congruent to KL, which must be congruent to LJ. All three sides have to be congruent to each other. So mark them all equal, and then come in JKL. Alright, and number 12, MNP, no sides equal to each other. So I'm going to be really extreme. There's MNP. No equal sides. Finally, triangle QRS with a measure of angle Q is 145. Really big angle. So we'll label that Q. It says the measure of angle R is 15. So I'll put 15 here, and angle S is 20 up here. Alright, our last group of problems are sometimes a little tricky. They're called sometimes, always, never questions. And it says determine whether each statement is always true, sometimes true, or never true. A right triangle is an isosceles triangle. Well, I can certainly draw a right triangle that's not isosceles, but then I could also draw one that is isosceles. So while it doesn't always have to be an isosceles triangle, it could be. So we would answer this with sometimes. Okay. A right triangle is an acute triangle. That one is never, because a right triangle always has a 90-degree angle. Therefore, all three angles are not less than 90. Number 16 often trips people up. It says an equilateral triangle is an isosceles triangle. That one's always, because an equilateral triangle always has a pair of congruent sides. It's just a more specific isosceles triangle. Number 17, however, is the converse of that. An isosceles triangle is an equilateral triangle. To that, we have to say sometimes. It could be in this case, or it might not be, as in this case. So one case where it's true, one case where it's false, we have to say sometimes. A scalene triangle is an obtuse triangle. To that, we'll have to say sometimes as well. Because a scalene triangle could be obtuse, right? But we could also have a scalene triangle that is acute. So that's why we have to say sometimes. All right, good luck on the practice and the learning check. As always, make sure you speak up and ask questions if you need some help.